Let's dive into a groundbreaking discovery straight out of the Lawrence Berkeley National Laboratory, Berkeley Lab for short. On March 17, 2025, a research team there announced they've created something entirely new, the first organometallic molecule with the element berkelium. They've named it Berkelocene, and I'm here to tell you all about it. First, what's an organometallic molecule? Simple, it's a compound where a metal bonds directly with carbon. This one, Berkelocene, marks the first time we've seen berkelium, a heavy and radioactive element, link up with carbon in this way. The Berkeley Lab team reported it in a news release, and it's a big deal for chemistry. Why Berkelocene? Well, the name nods to another compound called uranosine, which uses uranium in a similar setup. Picture this. Berkelocene has a berkelium atom sandwiched between two ring-shaped carbon molecules. That's according to Polly Arnold, a chemistry professor and the director of Berkeley Lab's Chemical Sciences Division. She calls it an organometallic sandwich, a highly symmetrical structure that's perfect for digging into the nitty-gritty of how berkelium behaves. Berkelium isn't just any element. It's one of the actinides, 15 metallic, radioactive elements tucked into the periodic table's F block. The heavy element chemistry group at Berkeley Lab has been working on these actinides, crafting organometallic compounds like Berkelocene. Why? Because their symmetry and the covalent bonds they form with carbon, those are bonds where electrons are shared, make them great for studying the electronic quirks of these elements. Here's where it gets exciting. Polly Arnold explained that they targeted Berkelocene because it's air and water reactive, and its sandwich design lets researchers probe the fundamental electronic structure and bonding of berkelium. What they found surprised them. Actinides like berkelium don't act like their cousins, the lanthanides. As you move down the periodic table, the f orbitals, these are specific electron paths, start behaving differently. That's a clue that our old assumptions need a rethink. So, why does this matter? For one, it's going to help scientists figure out how to separate tricky mixtures of radioactive elements in nuclear waste. It could also play a role in keeping our nuclear materials safe. Arnold says this discovery simplifies how we explain the chemistry of the F-block elements, actinides and rare earths included. These are critical for energy and technology, but they're barely touched on in undergrad classes. In short, Berkelocene isn't just a cool name, it's a window into the hidden world of heavy elements. Thanks to the Berkeley Lab team, we're one step closer to understanding the building blocks of our universe. And who knows, maybe one day you'll see berkelium in a textbook near you.